Good morning everyone, myself A. Bhargavram from KMCE and my project is about TransPolymer and I will be demonstrating through our UI. As you can see the navigation bar, we have features of our project where it explains the features of our project and we have how it works which tells us about the architecture and models pipeline from the molecular input to the application ready output. And you can see our business cases which are used in medical devices, material sciences and many more. Let's get started. Logging in through a demo account, as you can see, we have entered a dashboard where we can predict our smiles. For example, I predict ethanol. You can see the polymer structure, its molecular weight, and its six properties, which is electronic conductivity, electronic affinity, electronic band gap, ionization energy, refractive index, and crystallization tendency. And we have an interesting feature called Polymer tool, where the user knows the polymer name and doesn't know the smiles, it generates the smiles for you. For example, I try to get I try for polyvinyl chloride. It gives us the smile string, and you can just predict, and you can see its polymer structure, molecular weight, and its particular properties. And you can see we have recent searches here, so the user can go back to his searches, and I try to predict a benzene string. As you can see, its predicted properties, molecular weight, and its related polymer predictions. And you can see all our recent searches are stored here, and we can even clear the history according to our comfortability. Just we can close this and use this. And we have a chat AI integrated chatbot called Polybot, and we can ask it any question related to our project. Let's ask what is the use of TransPolymer. As you can see, it replies our answer in any way, and I'll just ask what is this aspirin. This AI integrated chatbot gives the answer for our questions, which is this. As you can see, it predicted the aspirin polymer structure, and when we try to predict a name instead of smiles, it shows an invalid smile string. And I'll guide you through our code. As you can see, the logic page of our login, where we set our email, set our password, and we use the set error for the functions, and we use this target so we can navigate to the dashboard. Using this try and catch block, using this try block, we connect our frontend to the backend through the string called HTTP localhost 3000 API users login. This uses HTTPS protocols, which is post and fetch, and using post method, we send our information of this JSON stringify of our email and password to the backend, and it verifies and checks if the password matches is true or false, and then if the response is okay, it navigates to our dashboard, and let's go to our sign up code where the same thing happens using the try and catch block. We will connect it to the backend using JSON stringify username, email, and password are posted to the MongoDB, and our login page checks the same password and email as the MongoDB and verifies the user and navigates us to the dashboard. API part of the code going to main.py, we use FastAPI for the API part, and we have imported our libraries according to our requirements, and we use this function calculate molecular weights to calculate the molecular weights as you have seen in the UI and generate structural images using import image from the pillow, and we use polymer name to smile, which is our polymer tools where you can type in the polymer name and you get the smiles tokens. I'm going to the model.py code. Here's the main transformer architecture where you import our libraries. And here's the part where we predict our six properties of each property prediction. We use class PolymerRegressor head and we inherit module. We have dropout rate of 0.3 and we have hidden state logging in from 512 to 1 in a reverse order. And we have an nn.relu. We use relu activation function for nonlinearity. And going to extract the our hidden state, we use CLS tokens, which is a common method to extract the context vector. And let's go to our backend part of the code where we connect our MongoDB to the local host using this string, and all our credentials are stored in a schema of username, email, and password, as you can see here. And I have written the schema over here. As you can see, username, email, and password. All these are integrated in app.js. We import these libraries and we integrate it to a port 3001. As you can see here, users can track the previous predictions, manage their profiles, and personalize the settings through an intuitive interface. The system architecture and design components of the frontend using ReactJS, backend using Node.js, and API as FastAPI, and database as MongoDB. The challenges faced in this TransPolymer are the PI1M dataset was too large of 1 million records, which was divided into 5 segments and trained them independently and combined encoder weights for unified deployment. Managing separate models for each properties introduced architectural complexity, which was helped through the backend. Frontend and backend synchronization was helped through fast API backend. The achievements are intelligent model architecture which can understand the smiles input and the tokenization, and well-structured code base understanding the modularity of the front-end and back-end maintaining for the easy maintenance. High accuracy and deployment readiness. We deliver over 80% accuracy along with a secure deployable production system. For the deployment strategy, we we thought of deploying front-end in Vercel and FastAPI in render, and the authentication, which is backend in render, and database in MongoDB Atlas for secure cloud storage for the deployment purposes. Thank you.